Welcome back everyone to another video. Arrange the following molecules in decreasing net dipole moment. We're given 4 structures and let's analyze them. We can start with the first structure and we can immediately say that it is nonpolar. Let's understand why. For the purposes of net dipole moment, we want to recall the concept of vectors. We identify the horizontal line of symmetry and we notice that there are 2 carbon-fluorine bonds. Right? Since fluorine is more electronegative than carbon, we can label each fluorine as partially negative, and each carbon-fluorine bond is polarized towards the more electronegative fluorine. When we add those 2 vectors together, because they have the same magnitude or the same electronegativity value, but opposite directions, that means the sum of those vectors is 0, and the net dipole moment is 0. So the structure is non-polar. For the second one, the same concept applies, but fluorine is more electronegative than chlorine, so we actually get a slight dipole moment pointing towards fluorine. So we are going to introduce a shorter vector for the carbon-chlorine bond. The longer one indicates a greater polarity or a more polarized bond. So actually there's a net dipole moment pointing upwards. We can say that even though both elements are, in this case, actually the 2 atoms are partially negative, right? Since each element is more electronegative than carbon, but fluorine is more electronegative than chlorine, so there's a slight net dipole moment pointing upwards. We can say that the net dipole moment is greater than 0. The structure is slightly polar, let's say sp. Now, there's the third structure. And in this case, once again, we have 2 fluorine atoms, but they're not on opposite sides. If we draw the 2 vectors that represent the individual dipoles, we notice that the 2 vectors are pointing in the same direction horizontally. So when we add them, we get a net dipole moment to the right. We can say that the net dipole moment is positive and the structure is polar. And the fourth structure, well, we only have 1 fluorine atom. So the net dipole moment is pointing upwards, right? There's no plane of symmetry. We're only considering the more electronegative fluorine atom. And once again, the structure is polar. So let's rank them. We want to arrange them in decreasing net dipole moment. And the greatest dipole moment would be observed for structure 3. Let's understand why. Well, essentially it has 2 fluorine atoms, so the 2 vectors are additive. They're pointing in the same direction when it comes to the analysis of the horizontal component of each vector. So that the first structure, due to the presence of 2 electronegative atoms pointing in the same direction, would have the greatest net dipole moment. Followed by the fourth one. Now, why? Well, essentially, when it comes to the comparison of the second and the fourth structure, the net dipole moment of the second structure is smaller because chlorine is canceling out the carbon-fluorine dipole moment slightly, right? We have an arrow pointing down, which is decreasing the arrow pointing up slightly when we add them together, right? As a net sum of the 2 vectors. So this is why 1 fluorine pointing upwards is better than 1 fluorine pointing upwards and another electronegative element pointing downwards that is canceling out the carbon-fluorine dipole moment slightly. And therefore we can say that the fourth structure comes next in our ranking, followed by the second one because it has a positive net dipole moment. And then, of course, we have the first structure. It is nonpolar, so it would have the smallest net dipole moment, which is essentially 0, the smallest possible. And that would be it. We have got the required ranking. Let's label it as our final answer and conclude the video. Thank you for watching.